Hi, this is Miss Borby.
And Mrs. Flynn.
Today we're going to talk about the quadratics functions. And I know this is review, so hopefully you know all of this.
All right, well, let's really quick. We talked last year before about quadratics. We talked last year about the Big Four.
What are the Big Four? The first one is the x-intercepts. Next we have the y-intercepts. Axis of symmetry, which can be abbreviated as the AOS, and can be found by using the formula x is equal to minus b over 2a. And the last is the vertex.
And you know the vertex is found on your axis of symmetry, so we can say it's negative b over 2a for the x value, and the y value is the function at negative b over 2a.
Wow.
So
very fancy notation there. Let's show it on a little picture.
A very neat picture, I might add.
Here we have a quadratic. Start with the x-intercepts. Those are the places where it crosses, of course, the x-axis.
And there's other names for this, Miss Borb. We could also call it
roots. Or like you can, on your calculator, you always calculate the zeros. So what you know from the x-intercepts is that is actually the solution to the quadratic when you're solving for x.
All right, another thing we know is the
y-intercept. Point where it crosses the y-axis.
And axis of symmetry.
Every quadratic is symmetrical, and the line about which it is symmetrical is called the axis of symmetry. And we know that the axis of symmetry gives us the x-coordinate of our vertex, which is right there.
Vertex is either your maximum or your minimum point. So your min or max of your quadratic.
Good.
All right.
We can write quadratic functions in 3 different forms. Let's go through the forms.
Okay, vertex form. First we have a parenthesis x minus h squared plus
k. Lots of variables in there.
Intercept form.
That is a times x minus alpha times x minus beta. Alpha and beta are simply the x-intercepts, right? And then we have the standard form, ax squared plus bx plus c.
Okay, let's talk about some fancy things we get for free.
What does that mean? What do I get for free?
Well, in vertex form, for free, I get the...
We're talking about actually what we want to find. If we want to find the vertex, for example, of the Big Four, right? So what do you get for free of the Big Four, right?
Okay.
So if you're in the vertex form, of course you're going to find the vertex for free. Anything else?
Well, we could find really quick the axis of symmetry.
Axis of symmetry, right? In this form, is there anything else that's really easy to get? Not really, right?
Okay. Obviously, in x-intercept form, it's easy to get your
x-intercepts. Anything else? Vertex, no.
Okay, standard form, the one thing that's easy to get from that is just
your y-intercept.
Y-intercept.
So what we can do is when we have a function, a quadratic function, we can switch between these 3 different forms, and they all give us different information very easily. But that doesn't mean that if you have the vertex form, for example, you can't find all 4. So let's do some sample problems.
All right, so we'll start off by doing this first example problem. Find the Big Four and convert into standard form.
What form is it in right now?
That's in...
intercept form. Yeah, this is intercept form. We want to take it to standard form. One thing we forgot to a value, right? Nope, not going to happen. Okay, in each one of these forms, the a always stays the same. Okay, so if you know what the a is in one form, you're going to know what it is in all the forms.
Okay.
Okay, so let's go back and do the problem. So,
all right, so the Big Four. So let's start off with what we know, which is our x-intercepts. And that just means when our y is 0, what is x?
So if we put y into 0 in for y, or for x?
If I write it out, I would have this. And now we all know, divide both sides by -2. I'm going to show you the long way first. Now we use our null property, so we have either 0 equals x minus 2 or 0 equals x plus 4.
From that, we know
2.
And x equals -4.
So that means our x-intercepts are going to be 2 and -4. And we also talked about the cover and solve. So we know if we look back over here, if we cover this whole fraction, or not fraction, that's not a fraction, this whole
expression,
term, whatever, then we can solve for when where y is 0. Blah.
Okay.
They're coming out. All right, so the second thing is
axis of symmetry, or what do you want to find? Y-intercept?
Well, we can do either one.
Okay.
If we find the y-intercept, it's easy if we look back here to find the y-intercept from standard form. And guess what? It asks us to convert to standard form, so we might as well go ahead and do that.
Right.
So now what do we do first? Because this is the question I got a lot.
This is a question like we had on the quiz, right? We wait to distribute the -2 until we FOIL out the x minus 2 and x plus 4.
So now I have x squared plus 4x minus 2x minus 8.
Okay, I'm going to multiply everything by -2.
Well, first I'm just going to simplify really quick,
Okay.
even though 2x minus 8. All right, so now I have
-2x minus 4x, 2x squared, sorry, minus 4x plus 16. Now we know immediately what our y-intercept is, because in this form we always know that it's the one number that doesn't have an x with it.
So there's our y-intercept.
Okay, moving right along, we can also find the axis of symmetry. And that's actually, we should probably add that to the list of the standard form when we go back up there, right? Or no? Because it's something that you can, once it's in standard form, you can use the x equals minus b over 2a.
Oh, yeah, I see what you're saying. So we could go back over here, and we could add that to standard form.
Standard form, right?
X equals -b over
2a.
will allow us to solve for the...
So in order to use that formula, it has to be in standard form. Right.
Axis of symmetry. Okay, so axis of symmetry, like we just said, x equals -b over 2a.
Okay, and how do we find b, a, b, and c?
So we could go over here and say a equals -2, b equals -4,
and c equals 16.
So we have negative, and then for b I put in -4. All over 2 times
-2.
-2. Just have to watch your signs. This becomes +4 over -4, which is
-1.
-1.
Axis symmetry is -1. And now how do we find the vertex from that?
And if we just look back to our first slide, if we know that our vertex has an x value of -b over 2a, then we just do f of -b over 2a.
Right.
So using our equation, which one should we use? Doesn't matter.
Not really.
So if we know x is -1, I'm going to pick this one because I think it's easier. -2 times -1 minus 2, -1 plus 4.
Good.
And we have to be really careful with our plus and minus sign, because Nadia, being the smarty pants that she is, caught our mistake. One of the last podcasts we had a mistake. So can't have any more of those.
Okay. I'm watching you, Miss Flynn.
All right, so there's our vertex.
Good.
That's it for now.